Okay, let's take a look at rain, clouds, and hail and how they form and where we can get them. Well, we talked a little bit about hail in the last one. That happens at a cold front. But let's say we have warm air. And the interesting thing is, as warm air pushes up over the cold air and it kind of pushes that moisture out ahead of it, if that cold air goes high enough, it's actually going to freeze. In fact, the interesting thing is, even during the summer, most of our rain in the summer gets high enough in the atmosphere that it actually starts out as snow. And as it comes through the warm air, it melts. And we can see that here. So if that's pushing up and that goes up high enough to freeze, as it falls down as rain and it hits that warm air, it melts and we get rain. But let's say this comes through and it heats up and warms up and goes from snow to rain, but then it hits the cold air again and it starts to refreeze. That's our freezing rain. Now, if we have it where it goes through just enough warm air to melt and come down and has longer to refreeze in that cold air, we get sleet. And if it's out in front of it, we just get snow because it doesn't melt as it comes through. It crystallizes as snow and falls as snow. So precipitation, that is water that falls from the atmosphere onto the earth, comes in the form of rain, sleet, snow, and hail. Now there's like mixtures of that we can call with funny names, but those are the four main ones that we would want to make sure you know for the test: rain, sleet, snow, hail. And this is just another example of that same thing going in a different direction, showing how we get rain, freezing rain, sleet, and snow. Use whichever picture makes the most sense to you. So what do we need to have for rain? There's a recipe for it. It actually needs specific things to occur. Well, first of all, we need air that contains some moisture and condensation nuclei. Basically, we need a dusty atmosphere. Condensation nuclei could be pollen, it could be dust that blows off the surface, it could be a sand from a sandstorm, it could be volcanic ash from a volcanic eruption. We also need air cooled to its dew point. Remember, cold air can hold less moisture than warm air, so it condenses its excess moisture. Remember that dry adiabatic lapse rate is 5.5 degrees, that should be Fahrenheit, per 1,000 feet, and wet is 3.5 per 1,000 feet. And if you want to go back and watch this, you can. It's a video on Rain's Dirty Little Secret, which is really talking about what I just talked about.
Somewhere inside of every raindrop is a tiny impurity. A touch of salt, a speck of soot, a grain of clay that's absolutely crucial to the raindrop's existence. In fact, without these microscopic pieces of dirt, there would be no rain, because water vapor can't condense into droplets on its own. Which is kind of weird, because water molecules like each other. If they didn't, they wouldn't cling to each other like this. And in the air, vaporized water molecules collide and stick together all the time, but they also break apart all the time, thanks to bond-breaking heat energy. Only when the air cools down past a certain point, called the dew point, does this breaking apart slow down enough for little clusters of water molecules to grow into droplets. But actually, that's only true if the cluster is big to start with. If it's too small, its surface is so curved that the molecules on the outside have few neighbors to bond to, which makes them easy to break off. So the cluster as a whole has higher chances of losing molecules than gaining them, even below dew point. Which means that up until a certain critical size, a cluster's chances of shrinking are better than its odds of growing. Unfortunately, that critical size is 150 million molecules. And while there are millions of 5-molecule clusters in a golf ball-sized volume of air at dew point, odds are that only one of those clusters will grow to a size of 10. And you'd need a golf ball of air 10 million miles across to find a single 50-molecule cluster, which basically means that clusters of water molecules never get to that 150 million mark on their own. Fortunately, they don't have to. They can start off at that critical size by condensing onto one of the gajillions of little pieces of dirt floating in our atmosphere, and then grow and grow until they're a droplet in a rain cloud. And ultimately, it's these little pieces of dirt surrounded by water that make life possible on our big piece of dirt surrounded by.
So basically, rain clears out the dirt in our atmosphere, and you'll notice sometimes if we've had a lot of dust in the air, and you look out at the cars, they're actually dirtier after the rainstorm than before it. So now let's talk about cloud type, and this will be on the test. So this is where you might want to take some notes, draw some diagrams of whatever works best for you. because remember, if you have it written down, it's a quick resource when you do it on your test. Cumulus, that is fair weather. They can turn into larger cumulonimbus, and nimbus again means rain. So it means a big puffy ball of clouds that turns into a rainstorm. But these are fair weather clouds. These are the ones that just kind of pop up and float and pop up and float, but they don't really rain. So fair weather cumulus. This is a cumulus cloud that's a towering cumulus. This is that cold front slamming into the warm front, and the only place the air can go is up. This is a towering cumulus. It's starting to grow. This is a fully mature thunderstorm. This is that anvil shape we were talking about, that little off flat top and then the triangular shaped peaks. Sometimes it goes all the way around, sometimes it goes in one direction. So this is a cold front related cumulus cloud, and this is a cumulonimbus cloud because we're going to be getting some rain. Stratus is kind of that overcast, and depending on the height, determines what the specific name is. So you can have stratus, which is low, all gray top and bottom. Altostratus is mid-level, which is kind of a sheet of clouds with gray on the bottom but white on the top because it's melted on the bottom and it's ice crystals on top. And then you could have cirrostratus, and cirro is wispy clouds, but it also means high, really high up in the air. And you could have cirrostratus, which are all white. Nimbostratus is a stratus cloud, big sheet of clouds that has rain or snow or sleet or something coming out of it. So if I have a cloud that forms on the ground, that's fog. Fog is really just a cloud on the ground. That's all it is. Cirrus. So now these are our high level clouds, and they're made of ice crystals, and the nickname for them is mare's tails, like a horse's tail. They're usually fair weather, usually an indicator of rain or snow could be occurring within a few hours because they're riding that warm front, and they're the precursors, the really far out where that moisture just kind of rode up so high into the cold that we just get these wispy clouds, and sometimes they'll look like little ripples, like little fish scales. So this is where you're going to want to go back into the notes and answer this question. When water vapor condenses above ground, clouds form. What ingredients are needed to form a cloud? So you need to be able to tell me what is the recipe for rain right up here. Next, we're going to be looking at classifying height and shape names. So the first thing that happens is the height name, okay? And that's determined by how high up in the atmosphere it is. So if it's above 20,000 feet, it's a high cloud called cirrus. If it's between 6,500 and 20,000 feet, it's a mid-level cloud called alto. And if it's below 6,500 feet, it's a low cloud called stratus. So our height levels are stratus, alto, and cirrus. Now, stratus also means a sheet of clouds, and cirrus means wispy clouds, so they start to get combined. Cirrus clouds are going to be white top and bottom. Alto clouds are going to be gray because it's melted water on the bottom and it's frozen water white on top. So gray on the bottom, white on top. And stratus are usually low enough that they are gray bottom and top. Unless it's winter and we're not getting into that. All right, so this is what you're going to do now. To name a cloud, you simply combined its height name and you add its shape name, and here's my descriptors. So a wispy cloud is called cirrus. A globular cloud is called cumulus, so a big puffball. An overcast, just so wispy, cirrus. Globular, like little cotton balls, are cumulus. And overcast, just a big sheet, is called stratus. So if I have a high level cloud that's white, top and bottom, and it's wispy, that's simply called cirrus. Okay? If I have a white cloud top and bottom, but it's little puffballs, that is called cirrocumulus. You just combine the two together. So cirrocumulus. Not great at writing with my mouse, but I'm getting better. And if it's a big white top and bottom cloud, but it's completely overcast, that's stratus. So it's now cirrostratus. All right. So now we've done the top ones. Let's look at the mid-level. So mid-level is alto. So that's the 6,500 to 20,000 feet. They are white on the top and gray on the bottom because they're frozen on the top and they're melted on the bottom. Alto means mid-level, and it's either going to be one of two. We don't get any cirrus here. We get globular, big puff balls, and that's cumulus. So it'd be alto cumulus for big puffball. And if it's a big overcast sheet, that's stratus, so that would be alto stratus. Low clouds, lower than 6,500 feet, generally gray top and bottom, those are called stratus. So the height name comes first, it's stratus. If it's globular, only wispy occurs at high heights, by the way. If it's globular, big puffball, that's cumulus. So that would be strato. We shorten it. Strato cumulus. All right. So this gets shortened to strato. If it's overcast and it's gray top and bottom, and it's a big sheet of it, well, we don't say stratus stratus. That's just, guess what? Stratus. And if it's a big sheet of clouds, that's stratus, but it's raining, then we call it nimbo stratus. Okay, so you need to go fill in those 8 height names. I am telling you right now, you need to study this chart because I will give you height name variations and you're going to have to tell me the name of the cloud. So you will see questions like this on the test. And you can fill it in. On the test, I would give you the names. You just have to tell me which combination is right for which part. This one is kind of tricky, but not impossible. This is that rippling effect. So those are cirrus clouds. This is cirrus clouds. This is mare's tails, cirrus clouds. There's a lot of opportunities for that. But this is raining. If it's raining and it's overcast, that's your nimbostratus, right? This one is the one I think is a little trickier because if you look really closely, it looks kind of gray on the bottom and whiter on the top. So that means it has to be mid-level. So that would be your alto, and that could be alto stratus because it's kind of, or it could be alto cumulus. So think about that. Does it look like puffballs? It doesn't really look like the puffballs I see down here. So I think I'd be more inclined in both of these to say those are like your alto stratus. This would be your cirrus. It's your rippling. These are your cumulus clouds. On the test, they'll be really clear cut. On some of these, I give you multiple, like there might be 3 different things I'm going to count as right depending on how you interpret it. But on the test, it'll be like, if you see this, it's raining, so it's more than likely nimbostratus. If you see something like this that's wispy mare's tails, you know that's cirrus. If you see these white clouds, you know those are going to be cumulus clouds. And they're white, so cirrocumulus. Again, now this, by the way, these were your clouds you're going to see at your warm front. The next ones are the clouds you're going to see at your cold front. And number 4, you need to tell me the names. So these are cumulus clouds, nice fair weather clouds. But if they get forced up because we have cold air running into warm air and the only place it can go is up, we have towering cumulus. And if it reaches the top where it can no longer rise because it's basically evened out its temperature, it's cooled to at the same temperature that's there, and it starts to flow out in all directions, that's our cumulonimbus, because now you have the thunderstorm and you more than likely have rain occurring. If this helps you, this is another option you can look at. And this kind of shows you the heights and what you'd get. So here's pictures of cirrus. Here's cumulonimbus clouds. Here's nimbostratus clouds. Here's cumulus clouds. And here are your fog and your cumulus, puffy clouds, stratus, nimbostratus, because that would be raining. And here's your cumulonimbus, and we can tell it's mature because it's got the anvil shape. But if you're way up high, we have our alto cumulus. So that's still mid-level, but now getting up into high, you've got cirrocumulus, and you could have cirrostratus, and you could have cirrus clouds. So use something like this if it helps you. Now, we've talked about this, but I really want to look at the development of hail, and that's in a mature thunderstorm with really strong updrafts. And you've got the cold air pushing in, forcing that warm air to rise, and you can get convection currents in here. And as that warm air rises and it condenses on condensation nuclei, a little piece of dust, it gathers water and it goes into the freezing point where it freezes, and then it takes a downdraft, picks up more water, gets caught back up in the loop, comes back up and freezes, and it just continues to get larger and larger and larger. And hail actually has a definition by size. If you want to read more about it, there's more reading in here. You can go back and look at that. This you're going to actually use to answer these questions. So I need to know the speed in miles per hour and the speed in kilometers per hour. So marble size, quarter size, tennis ball size. And if we look at this chart, here is the measurement in inches. And here's your miles per hour, and here's your kilometers per hour. So be careful which column you're looking at. Pea-size hail is a quarter of an inch across. Marble size is a half an inch across. Dime size is 7/10 of an inch. Penny size is 3/4 of an inch. Nickel is 7/8 of an inch. Gotta like the metric system. It's so much easier. 1.3, 1.8, 1.9, 2.2, but we're going to go with the inches because I know that makes more sense in your head. A quarter is an inch across. $half is 1 1/4 inches across. A walnut, that is the little nut before you crack it, is about 1.5 inches across. Golf ball size hail is 1 3/4 inch across. Hen's egg or egg size hail is 2 inches across. Tennis ball hail is 2.5 inches across. Baseball size hail is 2 3/4 inch. Teacup size is 3. Grapefruit is 4 inches across. And if it's softball size hail, it's 4.5 inches or larger. And so when you hear them say it's golf ball size hail or it's grapefruit size hail or baseball size hail, there is an actual size that goes with it. And updraft speeds, that's what we're really talking about here. How much speed of the updraft do you have to get this size? So in miles per hour to get dime size hail, the updrafts have to be 38 miles per hour or bigger. The larger we go, you need 54 miles per hour to get $half size. And if you want grapefruit size hail, you need to have 98 mile per hour winds updrafts to carry that heavy water, that hailstone, up again to add more to it. And to have softball size hail, that means you have wind speeds of over 100 miles per hour to make that grapefruit size piece of ice have enough power behind it in the wind to overcome gravity to get forced up and get more water before it falls to the ground. So the last thing you're going to do is now fill in this chart. This would be a great test question, but I would give you this chart. I would never make you memorize that, but I would ask that you can read the chart. And then I need you to explain to me how hail forms. Answer some more questions using that chart. And here's some pictures of hail. This is a hailstorm. We had a hailstorm once in the summer, and it was so thick with hail that when I had to drive down Highway 100, there were people had created ruts and it pushed the hail to the side. And to change lanes, you had to go over ice piles that were 7-8 inches tall and 1.5 feet wide. It was a lot of hail. That is a good sized chunk of ice. That's going to do some damage. You don't want to be caught out in a hailstorm. It will damage your car and it will definitely damage you. Here's some baseball size hail and some golf ball size hail. And you'll notice that they're not perfectly round. It depends on where the water condenses. This one actually went out in little spokes. And this is like what I drove through that one summer where you actually pushed the hail away. It had hailed so much. Hail is a precursor to really severe updrafts. And it can be the precursor to a tornado. It doesn't mean you're going to have one, but it just means you've got a really severe thunderstorm. Momentous clouds. I have seen these 3 times in my life in Minnesota, and they're associated with anvil clouds, so that severe thunderstorm, and they're also used, you will only see them in a really severe thunderstorms. You have some really interesting downdrafts and updrafts to get these clouds to form, and they're called momentous clouds because they look like cow's udders. That's what people thought they looked like. This is if you see this, I know with your phones you're probably going to take a picture, but this is the time to get inside and find some shelter. Again, I've only seen them 3 times in my life. And I know that when I see them, that is not the time to be dawdling and looking. Now, one of the videos I think actually looked at this that I had you watch, which was morning glory phenomenon. It results, it's just one place in the world off of Australia that this happens, and it's because water, there's a peninsula, and the water goes over the land, condenses, and then it's just a really narrow peninsula, and you get these rolling clouds. They're beautiful. Lenticular clouds form when you actually go up over mountains, and what happens is, as we have the mountain and air runs into it at different levels, right? Well, this gets pushed up and it gets, you'll notice, closer and closer together. And as that happens, you get these layers that form at the different heights. You've got different cloud levels rising, and you can get these beautiful lenticular clouds. And it all has to do with uprising air. And here's the nicer version of it. You'll see that air gets squashed together. And they can actually move off the tips of the mountains and get pushed along in the atmosphere, and then another one can be created. You can get these huge chains of these lenticular clouds. And they come in weird shapes, like that. You can see layers in there, but it actually looks like a cap. And the next one is even crazier. Look at that. That is a lenticular cloud. You also get a cloud when a sonic boom happens. If you want to learn more about sonic booms, we'll actually talk about that in 9th grade, but you can always Google it. As always, if you've got questions, let me know. But this is important that when you're done with this notes, you go back into the bottom of these notes, because I'm actually just going to put this at the top of these notes and answer all those questions, because they are practice for your test. If you need help, ask please.